S1 Regression Example 7. This is a full exam question. We very often get a full exam question on this topic. And it's really, really helpful to make sure that you do practice it, because it's the sort of thing where you can pick up a lot of marks. If we scroll down the side here, you can see that there's 16 marks, which is about a fifth of the paper. So it's really worth practicing these skills. So we've got an ice cream seller that believes there's a relationship between temperature and the number of ice creams sold. So it's worth thinking about the context. If the temperature increases, what would happen to the number of ice creams sold? Well, we'd probably expect that to increase as well, wouldn't we? We've got temperature, the number of ice creams. I'd be thinking about what goes on which axis. Which one affects which one? Well, the temperature would be the thing that dictated the number of ice creams, so I'd be expecting it to be that way around. We're given some summary data at the bottom. It's not all the things we'll need, but it's a lot of it. I think the other statistics we might need would be the sum of T. And if you quickly add that up, I think that adds up to 169. And I think we'll also need the sum of C. That's 357. And we know that he's done this survey over 10 days. So we've got to calculate the PMCC first of all. So starting off, start at the top here, we want STT, which is sigma t squared minus sigma t all squared over n. Working that out, sigma t squared is 3025 minus sum of t, 169 squared over 10. Working that out gives us 168.9. Now we've done this quite a few times, so I'll just write down what I got for the other two. Why don't you pause the video at this point and see if you get the same answers. I got 1500.1, and for STC I got 492.7. So pause the video and see if you can get those. Then for R, we do SXY, which in this case is TC, over SXX, so that's TT, SCC. So working those out, we get 492.7 divided by square root of 1500.1 multiplied by 168.9. And if we work that out, we get 0.979 to three significant figures. So that's 7 marks. If you practice that, it's a really straightforward 7 marks. State whether or not the value supports the use of a regression equation. This is one of those that we need to learn. This value is very close to 1. It's very close to 1. What does that mean? Well, it means the points are close to a straight line. So the points are close to a straight line. What does that mean? Well, if your points are fairly close to a straight line, then predictions are going to be accurate from a regression line. If your points are all over the place, there's no point doing a regression line because it's not going to make very accurate predictions. So therefore, a regression line is suitable. You would only use a regression line if the points were fairly close to a straight line, because that's how you get accurate predictions. So that's part B. We've now got to calculate the least squares regression line. That's just our standard regression line. We've worked out all those little STT quantities. So pause the video at this point and see if you can work out B and A and come up with the equation of the line. For B, it's STC over STT. Show the values you're putting in. And that works out to be 2.917, and store the rest in your calculator. A is Y bar. Now Y in this case is C, so it's C bar minus B times X bar. Well, X in this case is T. So sum of C is 357. Divide that by 10, so that's the mean of C. Take away B, the value you've got in your calculator, multiplied by x. So A works out to be minus 13.59 and some other numbers. So rounding them off to 3SF, A is minus 13.6 and B is 2.92. In fact, we shouldn't have Y at the front, should we? We should have C. So let's put C there at the front. Okay, so that's our regression line. Now it says interpret the value of B. B is the gradient. I always draw a little picture like this. So for every one along, we're going 2.92 up. That's this number here. So what does that mean? For every extra, now what is it in the x direction? Well, it's 1 degree of temperature. So for every extra 1 degree Celsius, what happens? Well, it goes up by 2.92. That's the number of ice creams. So an additional 2.92 ice creams are sold. You could approximate that to 3. For every extra 1 degree Celsius, an additional 3 ice creams approximately are sold. So that's interpreting the value of B. If you can learn that, you're at an advantage because a lot of people miss out those interpretation questions. So it's a good way of getting a little bit of an advantage. Estimate the number of ice creams sold between 1 and 2 p.m. when the temperature at 1 p.m. is 16 degrees. So the temperature is 16 degrees. If we substitute that into the equation of our line, again, you can make it really accurate by using the exact values of A and B. Work that out, and it comes out to be 33.12. So approximately 33 ice creams would be sold if the temperature was 16. Last part, part F, at 1 p.m. on a particular day, the highest temperature for 50 years was recorded. Give a reason why you would not use the regression line. Well, we talked about this earlier. If it's the highest temperature for 50 years, it's way beyond the data that would have been used to come up with this regression line, and therefore any predictions will be unreliable. So we would say making predictions outside the range of data in the question or in the table is unreliable. And you might even want to sneak in that word extrapolation to show that you know what you're talking about. You could also say that predictions would be likely to be inaccurate because the regression line isn't based on those very, very high temperatures when you get like an unusually high day. So that's a 17-mark exam question, all very accessible marks. So make sure you learn all of those techniques because, like I say, that could form over 20% of the exam.